This is the instructional worksheet, Unit 9, Lesson 3, Thermodynamics. You should have this. I handed this out a couple of classes ago. So make sure you have this, and please make sure you stay engaged. So first of all, we're talking about thermodynamics. Thermo, which means heat, is a study of how heat moves. This might sound like a really boring, dull thing to do, but it's a huge, huge thing in manufacturing. It's huge in cars. Heat is a big deal in our world. Let me see if I can get to some more colors here. Heat always transfers from hot to cold. This is something that will be on our next side of this. Heat does not rise. Hot air rises. Now this diagram shows us that heat is transferring from the warmer to the cold. This can also be thought of as higher energy, kinetic energy, to lower kinetic energy. So we can think of that heat transfer as from higher to lower kinetic energy. Insulators slow down heat transfer. Materials with air pockets are good insulators. One thing I like to talk about here is windows. Many of you have windows in your house that are double pane. Some of you might even have windows that are triple pane. And those windows, I'm going to just write this down here and then I'll erase that later. Like this is your window, and we would have in these blank spaces here, we would have pockets of an inert gas. So we have a layer of glass, then we have a gas, then a layer of glass, then we have a gas, and we have a layer of glass. That'd be a triple pane window. And these are much better insulators than just plain old windows. One plain window. Okay. Another good insulator that I always like to mention here are down jackets. And most of your down would be a goose down. Those be down jackets. And those tend to be very warm. They're filled up with down, and I generally have students who are familiar with this. I'm not there, so we're not going to talk about that in great detail. Conductors are substances that have easy heat transfer. Conductors easily allow heat transfers. Metals are generally good conductors. I always like to think of a metal spoon and a wooden spoon in a pan of boiling water. The metal spoon will get hot. You won't want to touch that one. So metals are good conductors. Wood is a poor conductor. So that takes care of just a brief, super brief introduction into thermodynamics. I'm going to erase a little bit of this so I've got some more room here. Now our next one we've talked about a little bit before. Whoopsie, what just happened here? And that is, I'm just trying to switch to a lighter color. Thermal energy or heat can be transferred by conduction, convection, and radiation. And we've already talked about these once. First, let's talk about conduction. That's the type of energy transfer that you'll be most familiar with. Conduction transfers heat through objects that are touching. So the operative words here are the objects have to be in contact. We know that all atoms are moving. All atoms are moving. Please remember the type of energy associated with movement is kinetic energy. So all atoms have kinetic energy. Atoms with a lot of heat, hot atoms, have more kinetic energy than cold atoms. And when hot atoms run into cold atoms, some of the energy is transferred. We can look at this diagram to bring that into a little bit more detail. If I have atoms with high kinetic energy, let's make this bigger. These have high kinetic energy. And when they bump into atoms, when they bump into cold atoms, this has low kinetic energy. When our hot atoms run into the cold atoms, some of that heat is transferred from the hot to the cold. If I have an object and I sit it, if I take an object out of a freezer and put it on the table in the room and I let it set, those objects, the object from the freezer, will come to the same, pretty soon both of these objects will be at the same temperature. We call that same temperature thermal equilibrium. If you have a bottle of cold water and you let it set out, it's going to come to the same temperature as the room. And we would say that that object is in thermal equilibrium with the room. Same temperature. Our last bullet item for our conduction is if atoms are closer together, it means there's more collisions. So solids transfer heat better than liquids or gases. Gases are good insulators, so they're poor at trapping or poor at transferring heat to lower objects. So solid objects are better conductors, gases are better insulators, and liquids, of course, are in the middle. And that is our talk on conduction. Next, we're going to talk about convection. Convection. And convection transfers heat through moving currents in gases or liquids. So the operative words here are gases and liquids. We know that hot liquid rises. We know that hot gases rise as well. The rising and falling of gases and liquids cause convection currents. Some of you might have convection ovens at home, and I asked a couple of classes about those convection ovens. Students responded that those convection ovens have a fan and circulate gases. Remember that gases transfer heat poorly. Convection currents speed up the thermal transfer because it keeps the gases moving. So again, convection currents can only happen in gases like air or liquids like water. They can't happen in solids because solids can't have moving currents. No currents, no convection. Much of the weather on Earth, in fact, virtually all of the weather on Earth, comes from convection currents. The sun warms the air on the surface of the Earth. Warm air rises, cold, and then it falls, and then that rising, falling makes wind. This is a very big deal for all weather. Our third type of transfer of energy is radiation. Radiation transfers heat through electromagnetic radiation, and it can occur even in a vacuum. In the world of science, a vacuum is considered empty space. It has no atoms. no particles, no molecules. Radiation moves through electromagnetic waves. One of these forms is light. That is a type of electromagnetic radiation. That is just one type of electromagnetic radiation. If you look at a light bulb, which is emitting light, it emits its heat in all directions, or its energy. I'm going to say energy. And it could be light in all directions. Convection currents always rise. So radiation can go in all directions. Let's switch colors again. I'm going to go with another light color here. Radiation transfers energy in all direction. Radiation requires no contact. It is the only type of energy transfer which does not require contact. Convection and conduction both require contact. So radiation can be transferred. You can see light, so it can be transferred from a point of origin to your light or to your eyes. Radiation can go through transparent materials like glass. So radiation can go through barriers like glass. Radiation can also go through barriers like water, or can change mediums. Every bit of energy here on our planet came from the sun. The sun energy travels through space that is almost a vacuum. So only radiation can travel through the space of the earth. You can't get energy from the sun by convection or conduction. Here's a couple of factoids that you know. Dark objects absorb more radiation than light objects. And if you're going to go outside in a super hot day and there's a super sunny day and you want to stay cooler, you should put on a light shirt. If you put on a dark shirt, you're going to absorb that energy. Here's another thing that I think most of you intuitively know. I want to get a lighter color here. We'll try this one. Dull objects absorb more radiation than shiny objects, which means that the shiny objects reflect. So here's dark objects, high absorption of radiation, they heat up fast. Light colored objects, lower absorption of radiation, and these heat slowly. Just because it takes forever to put these together, I'm going to stop this one now. You can turn over and get ready for the